Hi, today I'm going to do the modified CAMPLAY comparison with the UMAT and the inbuilt one in this Abaqus. So modified CAMPLAY inbuilt one called the porous elastic. So here I selected my density as 2 and the porous elastic kappa value as 0.0, 0.02 and 0.3 as the Poisson ratio. And here again I have a geostatic step for the gravity and loading step for this 14 is this one. So basically in this model what I am doing is I have a 10 meter by 10 meter model, and I have a 1 meter footing on top, and I'm going to load I'm going to pressurize it, apply a 100 kilopascal stress on top of that. But before doing that, during geostatic step, to capture if there is any stability occurs, for that reason I'm going to add another 10 kilopascal stress for the whole line here, 10 kilopascal pressure, and these three boundaries are restrained. So this is a simple footing example. Here you can see my loads. The first load is the 10 kilopascal, 100 kilopascal load, and the second load is the gravity load, and the third load is the 10 kilopascal uniform load. And so these are my boundary conditions. So these two sides restrained horizontally, and bottom one restrained horizontally and vertically at both. And I have defined two predefined cases. So I'm applying geostatic stress of 10 kilopascal at the beginning, and I'm defining my predefined void ratio as well as 1.6. So in this analysis, I'm going to use the specific volume as 2.6. Because of that one, I'm assuming void ratio is 1.6. Void ratio plus 1 equals specific volume. So specific volume is equal to 1 plus E. Then so these are the equations. So in modified CAMPLAY, the kappa value comes VP star over simple K. The bulk modulus is defined as VP star over kappa, and the G value and the total elastic matrix will be like this for a plane strain condition. So here what I'm going to do is I'm going to write the UMAT for this case. The UMAT I have written is here, and I have incorporated one STMini file, one state variable. So this is for the void ratio. So this is my initial specific, this is for specific volume. So this is my initial specific volume. And first I'm defining all my parameters. Then I'm defining my material parameters. And then I'm finding the sigma value, that means the pressure and the total strain. Then I'm finding the kappa value like this. Then G value, and I'm defining the elasticity matrix. And these are the stress increments. And then I update the stresses. And finally, I am determining the Jacobian. So since this is the elastic case, Jacobian will be the same as the elastic matrix. And this is the way I update the stresses again to the inbuilt stress functions. That means stress 1, 2, 3, 4. So stress 1 is for x direction, 2 is for y direction, 3 is for z direction, and 4 is for the shear xy direction. So I will be utilizing this file for this today's example. First, what I will do is I will keep the material model, the inbuilt one, and I'm going to run this file. So I'm going to submit this one, and I'm going to take that results into this Excel file. So the results, I'm going to get all the strain values, all the stress values, the primary values, and on this top node, E11, I'm going to copy and paste this in the Excel sheet. I'm going to copy this one. I'm going to paste it. And E330, it's plane strain. And this value. And so after I get these three values, so our Excel sheet will be like this. So our total stress versus total strain will be like that. So total strain means the addition of these three, and there is a negative sign here because I wanted to see positive values, and this is the pressure. It is also I'm adding these three and take the average. Then what I did was I got the difference between these strains, and I calculate the variation in specific volume using these strains I am getting from the Abaqus. And then here you can see I added a trend line here, and that trend line, this value gives me the exactly same value as the kappa value. So here this is specific volume. Specific volume, and the bottom axis is p value. Okay, so now what I'm going to do is I'm going to use the same model, and I'm going to do this one, repeat this one for the UMAT file. So I'm going to save it as a different file. So when I'm going to use it for the UMAT file, the main difference I'm doing is the material. So I'm going to delete this one, and I'm going to use the state parameters. So I'm going to use 5 state parameters, and I'm going to use the user material. And here for these steps, I use the incremental one, but for when I use the UMAT, I'm using the fixed case, and here also I'm using fixed with 0.01 increment. And then I'm going to write the input file, and I'm taking that input file, so I'm opening my input file. And here, if you can remember, last time I explained that you need to change this input file. So you need to copy, and you need to use, because we are using a STMINI file, so you need to copy paste this line or type that line and save it. And I'm going to create a new job file, and I'm going to use this input file, and my subordinate file is this one, and I'm going to run that. After I run that one, I'm going to compare that one with my previous Abaqus model values in this Excel sheet. And here I'm using the incremental size 0.01. And since the kappa value we used here is for the incremental case, when you are using higher number of incremental size, it increases the accuracy. Or here instead of using the incremental size, incremental case, you can use analytical solution as well. But this is the analytical solution for that case also. You can repeat the same with the analytical solution. And in the paper by Sloan, Dutch Ocean and Sloan, they are explaining why this is not suitable, having the tangent initial kappa value is not suitable. But that is for the research purpose. If you are doing this one for general cases, this will be fine using the incremental format. So I'm going to copy paste these values. This is 0. So finally, this is your final outcome. The Abaqus values and UMAT file values will be around the same. And it will follow the exactly same on the VP space as well. So if in case if you're interested in using a UMAT, you can try it, and both should give you the same values. And as I explained, you can do the same thing for the analytical using the analytical case as well. So I tried one earlier with the analytical and incremental. So since I'm using a lower stresses around 100 kilopascal, both gives me the around same values. But depending on the cases, it will analytical solution will give you the correct answers. But if that is for the research purposes. And I hope you enjoyed today's video. Thank you.